Welcome to Spring LIB.
Okay, we have a steel pipe and we're carrying it through a building and we're in a 9-foot hall and we make a turn into a 6-foot hall. And the question is, what's the longest pole that we could get around this corner if we were carrying it horizontally? All right, so we're trying to find the longest pole. So that means we are trying to maximize the length of the pole. All right, so since we have two things going on here, I'm going to go ahead and extend that line and that line so that I have two triangles. So I'm going to call this one, let's call this one L1 and this one L2. So we're trying to maximize the length, which is L1 plus L2. So now we got to find some relationships between them, and I bet it has something to do with this angle theta. All right, so notice that we have two parallel lines cut by a transversal. Corresponding angles are congruent. So if that one is theta, so is this one. Okay, also we have right angles here because these are all horizontal and vertical. And I know this is 9 and I know this is 6. Okay, because that's the length of the hallway. So in this first triangle right here, I have an angle, the opposite side and the hypotenuse. So I know that the sine of theta is opposite, which is 9 over the hypotenuse, L1. So L1 is 9 over the sine of theta, or 9 times the cosecant of theta. And then in this triangle up here, I have an angle, the adjacent side and the hypotenuse. So I have the cosine of theta equals 6 over L2, or sort of sorry, a little moving trouble there. L2 equals 6 over the cosine, which is 6 times the secant of theta. Okay, so now we have length equals L1, which is 9 cosecant theta, plus L2, which is 6 secant theta. So to find the maximum L, we need to take the derivative, set it equal to 0, and then we can answer the question. All right, here we go. We're taking the derivative with respect to theta, so it's 9. The derivative of the cosecant is negative cosecant theta cotangent theta, plus 6 times the derivative of the secant, which is secant theta tangent theta. And we want to set that equal to 0. Okay, I don't know about you, but I don't know anything very quickly about cosecant, cotangent, secant, or tangent, so I'm going to change everything to sine and cosine. Here's that negative and 9. Cosecant, 1 over the sine. Cotangent, cosine over sine. Plus 6 times 1 over the cosine times the tangent. Oh, I totally did those. Oh, no, that's backwards. That's right. Sine over cosine equals 0. Okay, so this one is 9 cosine theta over sine squared theta equals 6 sine theta over cosine squared theta. Cross multiply, 9 cosine cube theta equals 6 sine cube theta. Okay, divide the 6 over here, divide the cosine cubed over to the other side. And the reason I know to do that is because I want to talk about tangents, not cotangents. So 9/6, that's 3/2 equals the tangent cubed of theta. So then I need to take the cube root of 3/2 equals the tangent of theta. Okay, so here's a picture of theta now. Opposite side cube root of 3, adjacent side cube root of 2. Okay, and remember our formula for the length was 9 cosecant theta plus 6 secant theta. So we don't actually have to find out what theta is. We'll just use this picture. It's 9 times the cosecant. Oh, I got to find the other side here. Cube root of 2 squared plus cube root of 3 squared, square root. Ugh. Cube root of 4 plus cube root of 9. Yeah, I'm not too crazy about this. I'm not going to do it this way. I've decided to get out my calculator because this is too messy. It's not worth my time to do it that way because there'll be a lot of algebra and simplifying. All right, so I've got the cube root of 3/2 is the tangent, so I'm going to inverse tangent that on my calculator. Inverse tangent, cube root of 3/2, that will be theta. Okay, remember you're in calculus, so you got to be doing it in radians. 3 divided by 2 cube root, oops, 3 divided by 2 cube root, inverse tangent. I get theta is 0.85277. So now I got to do, because the question is find the length, I've got to do 9 times the cosecant of 0.85277 plus 6 times the secant of 0.85277, which is 9 divided by the sine, because I don't have a cosecant button, plus 6 divided by the cosine of 0.85277. All right, let's see if I can get it. 0.85277, the sine, divide by 9, reciprocal. 11.95 plus 0.85277 cosine, divide by 6, reciprocal. So I have to do mine upside down and then do the reciprocal because I'm using my calculator on my phone. Okay, now I'm going to add those together. 21.07 feet is the longest pipe that I can carry around that corner.